Yeah, I had gotten it's this game where there's like a planet and then you can like start like you can like throw asteroids at it and other things and just like watch it destroy. Oh yeah, that one.
Maybe I'll get it one of these days and start fucking around with it. But oh my god, yeah, Universe Sandbox is awesome. So in terms of black holes, how technical do you plan on getting when it comes to talking? Because I missed any sort of discussion about black holes outside of video games at this point. Um, but like, do you discuss formation or like any? I suppose anything in GR like rotating black holes, things like that.
Yeah, so
Or
there
is it?
was there
Yeah.
so, hold on. First I'm trying to figure out. I think I have to get onto with this as my main screen so I can because I just realized there we go. I realized that I that everything that we've just been talking about, the recording has only heard me this whole time. So
Oh no, they'll think you're like a schizophrenic or something.
I try to just put out information that I absolutely know and it's just easier that way, but um this time I think we kind of have to, and I actually do really like talking about the hypotheticals and theories and stuff. So when it
Yeah.
comes to like supermassive black holes, the formation is like the most uh, intriguing, I guess, to me. And so the
Yeah.
three that I wanted to talk about was the simultaneous formation with galaxies, growth from smaller seeds, and then the direct collapse from like the nebula itself.
Yeah, the floor is yours because I when it comes to astrophysics, um, I learned GR, so I know GR, and I can describe source field metric and Kerr metric and what have you, and there's some things that I've just kind of forgotten, but like when it comes to like black hole formation, like I haven't actually taken an astro class, and there was a bit of cosmology in that class, but I haven't actually taken any class for astro. And I mean the class I was planning on taking astro next semester, astro one, and then astro two the next semester after, but um, I'm currently working in condensed matter now, and it, because my advisor kind of uh you know was like, actually, I'm going on sabbatical. Bye. So I'm not regrettably, because condensed matter is fucking sweet. It's a lot cooler than I gave it credit at first. Um, but I'm just like, okay, well, I I have to lock in on this now because I'm kind of behind the curve in that sense, in the research sense. So I have to kind of drop Astro, which I'm kind of peeved about. So I might just audit it. That might be the move. I might just audit the class. But long story short, I don't know. Uh, I've gathered factoids, through my life just because of my all consuming interest in it. But I haven't learned it formally. So this is exciting. This is new. So now please shut me up.
The simultaneous formation. So I mean, the name itself just kind of says what it is anyway. But um, there's always been that question lingering. Um, which came first, the black hole or the galaxy? And so this just says like, as far as we know, based on as far back as we can see, especially looking outside of the Milky Way, that they probably started at the same time because all of the gas for the galaxy was there. And so they probably did form at the same time. But to me, when I hear that, it's like, okay, well, then one of these other options had to have happened simultaneously. So the seeding is, it probably started out as a massive star and then died very, very quickly to become a black hole, and then just started eating other things and becoming larger. And then eventually had the gases around it took form and became the galaxies that we see now. At least the spiral ones, because elliptical, that's a whole other. Ugh. I'm starting to get like shaky because I'm right next to my air conditioning and I have a short sleeve shirt on right now. So I'm trying to like warm myself up and talk at the same time. But that one does make sense, but also I think the direct collapse. I don't know why it's hard for me to say that word tonight, but that one I think does make sense too, because if uh, if the gas in the center, towards the center of these, you know, massive gas clouds that became the galaxies, if they're dense enough in the center, they don't need to become a star. They can just collapse into the black hole. But I mean, that can also, that one's the most recent of theories. So maybe the proposal came about because they finally got enough people to actually do the physics on it to say that it could have happened that way. I'm not really sure which one I think makes the most sense, because in my actual like lesson video, I said that it's probably all of these things happened at some point. Now in the text chat, I did put this side by side of M87 star and Sagittarius A star. I put those two in there because that's the one that M87 was actually the first black hole that we ever got an image of directly. We had the stars, the short video that's of the stars orbiting very quickly around the center of the Milky Way. We've had that for longer than the direct image that we got. But the first one that we got was M87. And then when we did get Sagittarius A star, which in this picture actually looks like squished a little bit, but you can see how similar they are with their the light all around them and the field. So let's see. I don't know if I have it on now. Since I have the Discord connected to my OBS, I can't actually share through my computer anymore. So I'm gonna have to try to find this. But the image that we took with the, oh, there it is. There we go. Okay, so I just shared the image of Sagittarius, the magnetic field. I mean, we got, these things all happened in like really a short period of time from each other. So the acceleration of the study has actually drastically improved in such a short amount of time. Now, I'm really hoping that we don't get a setback, but hoping that we don't. I think it'll just get even more of an understanding. And so the reason why I didn't say really much about intermediate mass black holes is because there's really not that much to talk about besides that they are like 100 to 10,000 times the mass of our sun, and the two possibilities that they have um, theorized, I guess, was that they come about through mergers between two stellar
Mhm.
mass black holes, or formation in dense star clusters.
Mhm. Yeah, I think those seem pretty plausible. I think there's so the two images of and the third image that you posted from the Event Horizon telescope. Um, I God damn it, I attended a colloquium not super long ago. It was last semester, and there was they were kind of explaining how the these images were taken and how why they look the way they do. Um, and I have forgotten some of it, but it's actually pretty damn interesting because they have to literally do ray tracing. That's and I mean in terms of simulating what it should look like, um, and how it comes up. Yeah. Fucking Sagittarius A star is literally the eye of Sauron, guys. But I can't tell if that's the dimensions or it's the kind of improvements that they gave it, but eh.
I had said not that long ago, actually, when I was talking about JWST, that it really should have been like a decade earlier than it was. Uh,
Mhm,
so here, where I am, we have one of the NASA visitor centers is attached to like the state science center. It's really cool, and so they have this big IMAX there, and one of the videos they were showing was of JWST, and it was called Deep Sky. It was like just so amazing. But
yeah,
just listening to like
especially
the
in IMAX.
story of yeah, but listening to like the story of all the people that worked on it and when it started, I was like, I mean, they were ready essentially like 2011, but then they just kept hitting snags and wound up just not being able to launch until, until they did, because they had all these issues that had to be figured out. Not just
Hmm.
issues like with the JWST itself, but like um, what do you call it? Administrative issues.
Hmm.
Is
The government bureaucracy
Yeah,
bullshit. Yeah,
bureaucracy is an issue. But
yeah.
yeah, I mean, it could
Hmm.
also be a little bit squished because we kind of look at it like sideways, whereas with
Hmm.
M87 star we got like a straight head-on view of it.
Hmm. Hmm.
So actually, I think I'm gonna reshare one of the in my all JWST channel. One of the very first ones was the image of all of those galaxies. Was it 19, I think? Okay, it's not letting me. I don't know why it was doing that. Okay, I'm gonna reshare it in this channel because I had asked the first one to comment on that like a while ago when I first started this was my mom, and she just said like I have no idea. But the question was how many of these galaxies have black holes in the center?
Hmm. I
And she's
haven't.
like, oh,
I'm
I don't
by the
know.
way, I'm not looking at it right now because I am making dinner. Um, but I will. I will just give a guess for Oh, you know what? Actually, I just put it in the microwave. Oh, look. How many of these have black holes in the center? I'm gonna look for the ones that have large ass gamma ray bursts coming out of the center. Uh,
So cool. What?
Said I've read more pages in like the last 2 hours than I've read in a year.
okay, I'll say 10. I'll say 10. Or oh, which ones specifically, or how many of them?
No, like how many?
Yeah,
Explain.
I'll say 10 then. I'll say 10.
Okay, so the answer is actually all of them.
Oh my God.
Yeah, so I showed my my 9-year-old. He's almost 10 now, but I showed him this
Mhm.
picture when it first came out, and I also asked him, and he was actually really good about pointing out which ones are like very obviously the where you can see the halo and then you can see the super shine in the center. But
Mhm.
I actually had at the very beginning when I first saw them, it wasn't as versed, and
Mhm.
I had it was IC 5332 right in the center. That one I was like, there's no way that one has one, and then maybe the one up
Yeah.
top doesn't have one. But then when one of the JWST documentaries I was watching said all of them, and I was like, okay, I have to go reassess this and like research this because I clearly messed up. And
Mhm.
like, because
Mhm.
this is my field, so I should know this.
Yeah.
And of course, at the time, it wasn't actually, I hadn't fully decided about if I was going to pursue it or not. So it's a
Mhm.
little bit more understandable. But yeah, the answer is all of them. And it's extremely rare. Like, I besides the satellite, like this, the smaller satellite galaxies, um, those don't have, the full, uh, see, this happens to me all the time. I get so in my thoughts, I'm so excited, and then I just forget. But yeah, so they all do, and it's really some of them. You can tell which ones are more like head on. We can tell which ones are
Mhm.
kind of farther away because they don't look as um, defined, and then also the ones that are aging. But I mean, yeah. So these are all, I believe, these are all spirals, and
Mhm.
that's uh, that's another thing that I've heard a lot when like watching other videos or just talking to people. The common question is, well, these things are, or these galaxies are in this type of shape that looks like they're, swirling into this black hole. And then that stems to, are we gonna, this whole galaxy just gonna fall into this black hole at one point? And the once you understand that they also have limits to,
Mhm.
how far away you can get from them with their, I mean, obviously their gravity isn't directly affecting us right now in this moment, but there is a limit, and we're not gonna fall in.
Mhm.
But when you see galaxies merge, that's another question. What happens to the black holes in the center, like us and Andromeda, possibly in the future?
Mhm.
Because I recently read something that it possibly also couldn't happen. Um,
Mhm.
that's interesting. I have to read more about that. But what's going to happen to them? So, one of the other JWST images was the four, there's either three or four merging galaxies. And you can very clearly see two of them are really close together, and their centers are like right next to each other. So, the answer there is a couple things can happen, and that's they can sit just outside of that zone and orbit each other and form a huge, like a massive galaxy from all of the remaining dust, or they
Mhm.
can crash into each other, and one,
Mhm.
usually the bigger one, winds up eating the smaller one, and then becoming
Mhm.
bigger itself.
I wonder if you can even distinguish them. Are they like electrons where you can't really tell?
Um, well, I mean, it
Like which
depends
one
on,
ate the which one?
yeah. I mean,
They just
unless
kind
we
of.
were to get like a direct, we'd have to, because of how far away things are and how long it takes the light to get to us, we'd have to sit in one spot for like, I mean, a lifetime to be able to,
Yeah.
if we knew that this, I mean, I guess the antennae would be a good example of that because they're pretty deep into their merger, but they're to us they're still just outside of that zone where their centers haven't exactly touched yet. In real,
Hmm.
in to their reality, they long have, but to us they haven't. So
Hmm.
it would take a long time of watching that to. I mean, it's like that photo finish, when cars are racing and
Hmm.
they have to
Hmm.
take that picture, or like the horse races, the stuff like that. It's like you would really have to slow down the image to frames per second and figure out which one, was eating the other one. But I don't think that's
Hmm.
anything we're actually gonna be able to see. I guess electrons is a good example because they're so
Yeah,
fast and
my idea is like all the information. So, there's the whole issue of thermodynamics, but I mean, aside from that, do you just say, okay, well, a black hole is, black, and so there's no real information that I can see, um, on its surface, and when they're spinning that quickly and they're gonna merge like that, yeah, they might as well just be indistinguishable. I mean, they're distinguishable by their mass, but
yeah,
who eats who is kind of I think for me that only makes me not skeptical. It kind of rubs me the wrong way only because it's like it's not eating in the sense that one of them survives, is they are just both annihilated almost, and a new one kind of forms.
yeah. So I mean, that's also kind of the idea for the um what is it, the seeding. So it's one thing when there's very clearly like a supermassive black hole that it's a stellar
Mhm.
mass black hole, like that's pretty obvious. Like the the smaller mass one is gonna get pulled into the larger mass one. Um, but when you have similar mass objects, like two stellar mass black holes, that then um, combine, you can't really, like, there's no way to tell if one is actually eating the other one or if they're just combining to make a new black hole itself.
Mhm.
So I think that's the idea for the intermediate mass black holes. Like they have to
Yeah.
just be a combination.
Mhm. There's some really wacky things that can happen with supermassive black holes, especially when they reach like the upper limit for what we've seen, where it's like, oh yeah, this one, oh that black hole, yeah, it's just the size of our solar system, actually larger. Like, oh fuck, okay, damn, that is crazy. That is absolutely insane. That the radius of, like, for example, Ton 618, its radius is 25,000 astronomical units. That is fucking ridiculous. That
Yeah,
is like
it's
that's
so
incomprehensible.
huge.
If you put it at the center of the solar system, nothing would survive. It would just be all engulfed by this massive black hole.
Yeah.
That's crazy.
So I
And not to
know,
mention the accretion disk. Like, Jesus.
yeah.
Yeah.
And I mean, I know, uh, uh, so, well, one of the other things is a primordial black hole, but
Hmm.
those are that's getting into like strictly a hypothetical there because
Hmm.
um I mean we did get quite a shock when we looked back and saw galaxies that were larger than we ever thought they could get as young as they were. um
Hmm.
but yeah, the theoretical part of that is just a little bit beyond where I'm at right now. So
Hmm.
I like to just stick to the. It's kind of funny that like when we look at our solar system or our sun and even and then look at Sagittarius A star, like our sun is huge compared to us, and then Sagittarius is huge compared to our sun, but then when we look out there, there's things even bigger, like a mosasaurus versus a humpback whale. it's
Hmm. Yeah.
but it's also not frightening because they're so far away that it's not gonna they're not gonna get
Yeah.
you.
Yeah. Yeah. It's for me, it's really awe-inspiring. It's the, like, when you see something super huge. Yeah, exactly. It's just like, oh my God, when you see a huge whale. But like, if you're right next to the whale, then you have the right to be a little scared. Um, but yeah, I've always liked, and I think a lot of people like these kind of videos when just judging by how they do on YouTube, but like the size comparison videos, those are always really fun.
Let's see. I could probably get some up, but I did in my video. Oh, actually no, I already shared it. So in the streaming text, I shared a a YouTube video, and that's something I watched like a while ago, but then um I found it again today, and I was like, oh, I gotta use this. But it's
Mm.
just like a if you're just kind of flying in a ship and you're not definitely gonna die if you go into this thing, but you're gonna do it anyway.
Mhm.
And so um, it just shows what it would look like to an observer if they went into a black hole without any consequences. And
Mhm.
it's like, I mean, I know that uh, Hollywood, they don't always like, well, actually, very often, most often, they get things completely wrong.
Oh
And
yeah,
I mean, they do that on purpose because they don't care. It's just for
it's a
ticket
plot
selling.
device.
But Interstellar
Mhm.
did a really great job with the
I'm
actual
about to say, yeah.
science of black holes. I mean, that's the first time I had seen a black hole in a movie or even in like shows and stuff that are supposed to be scientific that actually looked accurate.
Yeah.
Now, of course, with black holes, it's easy to get into that theoretical realm where he goes in and it's actually a fourth dimension and he can go back in
It's like
time. But
books.
I mean, that would be cool. But um,
Yeah. I don't think that's I mean, like Penrose diagram wise, that's like still not once you enter the horizon, you can't go back in time. You would just be ejected through a white hole into a separate, like an alternate universe, or
Yeah,
you know,
or a different
die.
part of our universe. I mean,
Yeah.
yeah, for sure it would, like, you wouldn't be able to make it past the event horizon in
Hmm.
one piece, but
Yeah.
if, I mean, if you could, you know, the
Mhm.
main theory
If
is
you
that
could
you'd come out the
stretch
other
your,
end.
if you what was it, the Einstein-Rosen bridge only it goes down to like 0 dimensions at one point where it's just like you
Yeah.
can't get through there, basically. Um, what was it? The relativistic jet. Um, that is something that has always been very interesting to me because it kind of reminds me of the Harry-Ball theorem in mathematics.
What was it
Are
called?
you, the theorem or the jet?
The jet.
No, is the relativistic jets, right? So some of the matter from the accretion disk just kind of like shoots up, I think. Um,
Yes. Yeah. So, I mean, usually that's in the form of synchrotron radiation, which
mhm,
is like, I mean, it's so cool. That's something I didn't even know. Well, I've never heard of that until I started researching active galactic nuclei. But I mean, so those things, the jets, we will only ever see them when they get further away, or when we observe them from further away,
mhm,
because those tend to be in early galaxies. So the farther away we look, the more likely it is that we'll see them. Whereas like us and Andromeda, the two major galaxies in this group, aren't going to have them because ours are older and uh, they
mhm.
tend to calm down once they've eaten everything in the center.
Uh-huh.
But yeah,
And that is
those.
interesting because in Space Engine, on 618's black hole, like because obviously 10618 is the galaxy.
Mhm.
Um, and so the central black hole, right? It's like the really, really fucking big one. Um, I mean, 10618 is an elliptic galaxy. No, no, I think it is. Hold but the point being that there's no more. Yeah, it's an elliptic galaxy. So, like, point being that there isn't much matter left, right? There's no new star formation. But Space Engine thought it would be a good idea to still give it, a large ass accretion disk and relativistic jet. Um, so I think that's probably more just to like make it look cool rather than to actually be, accurate. Um,
Yeah, I mean,
but
it does
so
take a
I'm
long time for them to lose that accretion disk. Um,
through.
because things, I mean, things when they break apart around it, it's not like they just immediately fall in. It takes time for it to
Yeah,
it orbits and then gets closer and
yeah.
closer every time.
It turns out things do have angular momentum in space.
Yeah.
But there is the no hair theorem, which is not the Harry Ball theorem. Are you familiar with the Harry Ball theorem? It's a funny sounding name, but
It
I
is, yeah.
swear it's an actual algebraic topology. It is an actual theorem. Oh, the hedgehog theorem. That's such a better name. Who wants the name Harry Ball theorem? Come on. Um, but yeah, you can't comb a two-sphere, kind of continuously without any sort of tufts in any sense. So, you have to have either a divergence at one point or a discontinuity at some point or zero at some point. Uh, it's an interesting theorem. And I mean, it's true, but it turns out to not really have much to do with the no-hair theorem, which is the black hole uniqueness theorem. Um, which I don't know which one I can assume that you are more familiar with, but since this has to do with black holes, I'm gonna assume that you are more familiar with the no-hair theorem or the black hole uniqueness theorem, um, as opposed to the hedgehog theorem. Oh.
Okay, let's see. I'm gonna.
Yeah, a stationary black hole. Okay, yeah, all stationary black hole solutions of the Einstein-Maxwell equations, um, NGR can be completely characterized by three parameters:
Yep.
mass, angular momentum, and electric charge, which makes sense. Hmm.
Yeah. So, there was something that. See, I I do retain a lot in class. I do, but
Hmm.
it was like the last day that my professor was like just offhand talking about this thing, and now I just kind of forgot it. But he was talking about black holes and um how they continue to uh age and eventually they will go into nothing. And it takes a really long time. But
Hmm.
uh he was talking about how um one of the theories is that at the event horizon, as particles as atoms get pulled in, they can I would assume it's because of the spaghettification. It applies to all things, right? And protons have mass, so it would create. See, this kind of does in a bit go against the um, nothing created. You know, you can't create something out of nothing. But I forget the reason that he gave for why this happens, or why they think it happens, and that it would be creating a uh, shoot, what is it, the anti proton. For some reason I'm forgetting the actual name of it, but it would be creating the opposite, but then it immediately pulls it in. So it's not like it's not like it's setting it out there to us. So it's not like it's creating it and then sending it out there. So one of the ideas for why black holes do die, instead of just remaining this super dense mass, is that they do that they create this as they're pulling in one thing, they create the opposite thing and pull that in as well, and it, like, I guess, balances it out and uh ages it, I guess. Like, I mean, I can't relate it to anything that we've seen over here. um Also, I mean, unless we were to get like a sample, and then like a sample of the accretion disk, and then like test it under a microscope, that's not something that we would be able to find, I guess. But I mean, I thought it was a pretty cool idea.
Mhm. Yeah, the Hawking radiation. Um, yeah, I think the general um way that it can be thought of is like, the as you know, the event horizon of a black hole is not like on the black hole.
Yeah.
It's before the actual surface of the black hole, usually well before it. Um, almost necessarily well before it. Um, And so what you have is, due to fluctuations in quantum field, you have particles and antiparticles being, created and then annihilated
Yes.
all the time, right? One particle will be created behind the event horizon, and then its corresponding antiparticle, or vice versa, will be created outside the event horizon, or with at least enough momentum to escape the event horizon, or something like that. And yeah, what ends up happening is that one of them is lost forever.
Yeah.
And this is interpreted as radiation. Um, and I think there's a way that Hawking was just like, yeah, so black holes actually have to lose angular momentum this way, and that kind of has them lose energy. In any case, um, one
Let's
thing
see.
that was, yeah, I think
Okay. So
lensing is one of those things.
I'm gonna try to open. Where is it? I can't find. I can't find it now. But let's see. I'm gonna try to open the in voice chat and use that instead, because if I get out of where we're actually talking, OBS won't pick it up anymore. So, because that was my issue before. Actually, I found my notes, and so now I can look back at them. But there's the in the image that I will try to find out how I can share it. There's the escape velocity
Mhm.
and uh, where where the event horizon is, and then there's like the arrows start in the center, and one is you cannot escape, one
Mhm.
is you might be able to escape but probably not, and then the other one is
Mhm.
yeah, you'd still be able to escape. So
Mhm. Mhm.
what I do find the most interesting though is that the the high gravity makes it um so that an observer who is sitting like, we'll say the observer is pretty far away and you've taken off on a little like personal escape thing, escape rocket into this black hole. But the observer is just sitting there watching you, and they'll see you go away, and then they'll see you like slow down until eventually you just stop. And then to them, you don't move again. You just slowly start to shift to red until you just look red, and then you turn black.
Yeah, it's terrifying.
Yeah.
And like you're you can see their time kind of start to slow down as well, right?
Yeah.
Yeah.
I mean, that's the whole point of relativity, right? Like
Mhm.
you're seen from, both sides are going to see like, oh, no, you're the one who stopped moving. I was still moving. No, you were. Like,
Mhm.
that type of argument.
Yeah. Yeah.
Okay, so yeah,
Yeah.
I found my I should have surprisingly I did not at all try to look through my old notes like before doing this. So I did find my notes on there's not much of it cuz he didn't actually start talking about it until quite later in the semester.
I need to look through my old notes for GR, or I'll probably just take a look through Sean's book. Because there are some things like, for example, like time dilation due to gravity. I'm just like very foggy.
Yeah, so
I
time
need to.
dilation, actually, I still have a very old. So when I started actually going to school, I did try to write my notes by hand, and then I quickly realized, like, in my chemistry class, there's no way I'm gonna be able to do this. So I just started typing. But with my old notebook, where I started before I decided to actually go back to school, I was doing things like Coursera to try to see if I could, if I could do it, if I could actually do the the work, I guess, because this is my second time back, and I'm older now, so I don't know. My mom
Yeah.
always kind of put it in my head that when when I was younger, that like math was hard, but then as I got older, I realized it wasn't, and then now that I'm even older, I'm like, it's not
Oh,
hard
it
at all.
is.
I need to stop putting it off. I just need to do it. But I did
Oh,
take
well,
a special relativity class, the very first thing I ever did. So
nice.
yeah, I was like, you know
Yeah.
what? I'm gonna
If
go for
you,
this. If I can get through this, I can get through it.
yeah, if my a word of advice is that if you still if you think that math isn't hard, then you haven't looked at enough math yet, because there
Oh
are
no, it's
some
definitely hard, but like,
ridiculous.
um, when it comes like when I do math, like my mom is very smart person, um,
Mhm,
but she's just not like mathematically inclined, and she'll tell you that. She's not shy about it. But
mhm,
um, I realized, I think, uh, when I actually started working like real jobs, that when I was working at restaurants, like I had to do like really simple things, like but on the fly, and calculating
mhm,
tax on the fly is not like a super easy thing to do,
mhm.
because I was at like a really old restaurant, so we still had like a sheet that we had to base our tax off of, and then just kind of add it as we're going along. We didn't have like the computers like they have. But I'm trying to find the actual notes on. Oh, actually, I think time dilation is towards the end when he starts talking about um, just leading into general relativity.
And you've taken general relativity?
Oh no, not yet. I had to redo a lot of the. I have to redo a lot of like the math and stuff because, or not
Mhm,
redo, but when I was in high school, I didn't. I think so. I did algebra 1 and 2. I did geometry and stuff. Like I did those in high school, but I didn't really go much further than that because it wasn't required. And then
mhm,
I only did statistics for my first degree because
mhm.
I thought that most applied to what I was doing before. Well, I mean, which it did. I was doing journalism, but I was doing like political journalism, and so statistics is kind of a lot of that.
Oh yeah.
But yeah, so now I've got to anything I didn't give them any of the completed Coursera stuff. I'm just redoing it
Mhm,
because with Coursera it's self-paced, so it's kind of easier to just like go through things on your own. But then for me, I need both. I need to be able to like take it home and review it, but also get somebody who can tell me what the heck is going on.
oh yeah. I
So
can't. I'm like I will self-study when needed, but I would rather just take a course on something. It's way better that way.
yeah, I
I'm
mean,
trying to find.
I think I realized that going this is the first time I've been back like in an on-campus school for 14 years.
Mhm.
So it's been a
Oh
while.
man.
So I didn't even remember like. Also, I was really young at the time, so I didn't really care about going to class.
hmm Fair enough. Fair enough.
Okay, so as for time dilation, the it's such a brief thing because um, the course was on special relativity, and so the time dilation part of it is kind of small since
hmm
it wasn't about general. He just kind of um,
I mean,
had to
time
talk
dilation is
about
part
certain
of
things.
both. No.
Yeah, let's see. There we go, because we have. Oh, there we go. Oh my gosh. This is why I try to write in like different colors so when I go back and look, I'm not lost.
hmm
Yeah, so with let's I mean if we were to go do something local, like let's say we want to go and see Sagittarius A star. It's
hmm
uh it's far away. I mean obviously, but
Yeah.
uh speed, acceleration and gravity have similar effects. Um
Mhm.
that's one of his premises. And
Mhm.
if you were to go, hypothetically, if we had the ability to go as fast as we would need to for this to actually matter, um, you'd have to take into account the speed that they're going at is going to slow their clocks down. Whereas for us, we're going to feel it normally. But also, as they approach the black hole, it's going to slow down even more. And with that, even with slowing down to turn and go and go back, because you have to, you know, you accelerate and then you'd have to slow down a little
Mhm.
bit to be able to turn around and come back. But
Mhm.
to them, time hasn't gone, but what like we had calculated 0.943 uh, times not full speed of light, just below it would have been like 5.3 years to this person. It was a 5 year trip for them. But to us, it would be. Uh, I didn't write the end factor, but it would be like 60 years
Mhm.
about
And how
really
fast were they?
0.943.
Wow. Wow.
I mean,
Yeah.
that's something that I don't. The human body is not capable of actually sustaining that.
hmm
But I mean, if it could,
Yeah.
that's about what it would be, and
hmm
just
I mean,
that's
the human
not.
body isn't capable of accelerating, to that in one go, I guess. I feel like if you slowly, then the human body can take it because velocity is relative, so
Yeah,
that's not
yeah.
a issue.
If you allowed the body to build up the inertia over time, it would be a lot easier for us to handle it. I mean, we're technically our
Just
bodies
look
are
out
moving
for
really fast right now, but we're not gonna feel
Mhm.
it
Mhm. Yeah, just
unless
look out for space junk.
yeah. Yeah, well, space junk and just like going that fast, just ordinary particles would rip
Yeah,
into you.
literally. Oh no, hydrogen atom, boom, you're done.
Also, that's not even getting into the fact that all of the background radiation that has, shifted to the red now would become blue, and so the cosmic microwave background would just become all light around you. So you'd probably get super disoriented just from that.
That's interesting. Yeah, I hadn't thought about that. Yeah, no, I'm sure that that would happen on your way to the speed of like to point 94, just because at a certain point it would just become well, no, I guess I'd have to think about that, but yeah, you would certainly have a light show at one point. Let's see. Okay, yeah, so I guess that's not something that we needed to really calculate. So yeah, I mean, in my notes, I don't really have many calculations that are like, calculate the time dilation here. Um, because from what I remember, it's not actually super, it's not like a very unique thing. Like you can do it just, let's see. So in special relativity and general relativity, there's something called the proper time, right? Which is the time that an observer measures on their world line. So,
Yeah.
the trajectory that they're taking through space and time, what they are measuring is their proper time. And that's really the only significant time that you need to take into account. Um, because, uh, well, it, if you're the observer, that's the only thing that you care about, we'll say. Um, and let's see, actually measuring that time really amounts to like calculation wise. I think it's just you just contract the metric now. I don't think it's that's super difficult, but when it comes to figuring somebody else's like the time that you would see them have, that's a little bit more complicated. That's a good exercise. This has inspired me to look back into GR because I've forgotten so much. I mean, because I need to. As a world line of. Yeah, I think at that point, um, you know, in terms of you could just do it with special relativity if you're talking, velocity wise. If you're doing like a time dilation calculation, you could just do it special relativity wise.
Yeah.
But from curvature, that's a little bit different. Curvature has to do with the stress energy tensor. Um, and that for that you need the field equations, and I did not work with it as much, and when I did, we didn't really care about time. Um, tomorrow, so I'm going in tomorrow morning, and which means I should get to bed soon. But I'm
Yeah.
going in tomorrow morning, and I forgot to take a picture of something that I really wanted to. So I'll do that. Um, but I'll also ask my astro professor and my GR professor, the same person, and he's also my fucking academic advisor. Um, so I'll just ask him about how curvature affects time dilation. Because we didn't really go over that in class. He was more concerned with like the stuff that really matters in astrophysics. Um,
Yeah. Yeah.
because that's
Mine
what he
too.
does.
And that's actually kind of funny because my astronomy professor is also my academic advisor. but
Oh
and
yeah.
he's not even
Funny how that
actually
works out.
he's not the astrophysics lead actually. He's
Mhm.
he's the physics, like he runs the or not runs the physics department. That's a different guy, but he's in the physics department, not in the astrophysics department, because our astrophysics department is brand new. I mean, I think this was the first or this past school year was the first time they were actually running it. But there's two books. The 100th anniversary edition of Relativity came out, and it's both of them in the book. And so they took all of his words and his papers and put them in here, and then there's some commentaries from two other people, but all of his actual like papers are in here, and it's really cool. They have it. They probably have it at libraries, probably at your school library too. But also, if you want to buy it, I know they have it online at like Amazon and Barnes and Noble. And then there's another one that I got, Leonard Susskind and Art Friedman, and that's Special Relativity and Classic Field Theory. And I've been trying to pick which one I want to actually finish first, because I haven't actually read General Relativity from the actual paper yet. I've read a lot of the research, based on it and from it, but I haven't actually read the whole paper itself on my own. But this Leonard Susskind, I've heard a lot of good things about him too. So two books I definitely.
Suskind is one of the great minds of kind of the latter half of the 20th century that really kind of ranked through with a couple of other people a lot of really interesting things about not just GR but also quantum. But he focused quite a bit on black holes, so I think his books would be interesting of interest to you.
Yeah, and I also just I like having that too, because I'm gonna have to take all of the. I'm gonna have to take all of the physics courses as well as the astrophysics ones that they put in there. I mean, most of it was already in the one that the one that I took previously, which I've actually taken twice now, I guess. But the one that I took at my school was a bit more in depth.
Yeah, but I haven't asked where like what year are you? What is like what's your current standing in terms of, courses taken, courses like that you're gonna take, things like that.
So I actually I did the supplementing all summer and fall last year, and then I decided to actually start in this past spring. So at my school, the only semester I've actually done through my school was last semester. But I did ask my I asked my advisor if I could. He said I could have transferred some of them, but I just didn't really want to. I want to go through it again.
Yeah.
So yeah, that's why it's gonna take me a little bit longer, because I'm just gonna go through everything all over again, including I had to take an actual placement test. So plus I have to do coding.
Yeah.
And the coding is I don't know. It's like I'm excited but not at the same time, because
Yeah.
I don't know. It's more that I'm not looking forward to. I upgraded my computer, but I don't know if it'll actually do what I need it to do. So
Yeah,
I mean,
unless you have like a, the HP from 2003. Ooh, that rhymed. Unless you have some, really old computer, you should be able to run pretty much everything that they'll want you to run, maybe until you get to simulations and like for like in C or something. But
Yeah. Well,
eh,
I actually
until
did.
then,
I have DS9 on this computer, and I do run it. And it doesn't like lag. On my previous computer, it um it would take like 5 minutes to upload any or to load any of the images. And
Mhm.
have you seen DS9 at all?
No, no.
So DS9 is the software that you run Chandra data through. So the Chandra X-ray images, you can look at all of those. And the database that
Mhm.
I use for it is through Rutgers. Um,
Hmm.
and it's pretty cool. You have access to so much data.
Mhm.
But I mean,
Oh, sweet.
it works well on this computer. And I haven't
Mhm.
actually had an issue with OBS either, which, takes up quite a bit of space as well. A lot of
Mhm.
a lot of power.
Yeah, my personal um opinion is that Python is, I mean, what you're going to start with when it comes to coding is most likely Python.
Yeah, yeah. We
Some
only have
schools
two
might do
options.
MATLAB.
we
Yeah,
have we have Java and Python, and I definitely
yeah.
choose Python.
Mhm. It's a good choice. It's so much easier.
Okay, so um I think all of the main things about the actual black holes that I wanted to talk about, I talked about, and mostly everything is shared. I
Oh yeah.
There's a few things that I'm gonna have to
Mhm.
share after I get off because it's on my computer. Um,
Mhm.
but yeah, I think that's about it. And I was actually hoping to be done before MC Tune, but that was like 20 minutes ago. So
Oh yeah. I'll have to, yeah, I'll have to,
Yeah.
watch that. I had to
yeah,
ask him
I'm still
about
gonna jump in, but I won't be in there
collaborating at
for
one
long.
point. Yeah. Yeah. Is he streaming on Discord?
No,
I said it
I
on
mean,
YouTube.
he's on
he's on
YouTube.
YouTube.
Yeah. I don't know if he did it multiple places at once.
Oh, no. I mean, I don't usually either. This was just, I wanted to, for the black
Yeah.
holes one, I just wanted to chat with people because that, you can talk a lot about them.
Oh yeah. Like for days. Yeah. Well, congrats on the successful black hole stream. I have Sauron.
Yeah,
Oh
of
my
course.
gosh.
Yeah, I wouldn't expect anything different from Adam, so.
Perfect. Exactly. Also, I sent a link for Galaxy Zoo. I didn't realize this, but apparently they're done. Galaxy Zoo, if you're unfamiliar, is basically you just classify it. It's like a crowdfunded um project where they just have pictures of galaxies and you can basically just volunteer for free to classify the galaxies. And it's
Oh,
pretty damn cool.
that's awesome.
Um, unfortunately, I think they're done. Like they've just classified everything. Um,
Yeah, yeah,
but
it says thanks, we've clarified or classified
yeah,
everything for now. Check
yeah,
back soon. That's
it's
definitely
ridiculous.
something that I'll
Everybody,
keep
yeah.
on my favorites list there.
Hmm. It's super cool because there were some pretty like wacky ones that you could classify anomalies and stuff. It was cool. So yeah, definitely. Also, like probably ping me when that comes back on because I won't be checking it. But yeah, that should be sweet. All right, yeah. it is past my bedtime, so I'm gonna head
Yeah,
out.
it's approaching mine. I gotta go too. But yes, thank you
All
guys
right.
for joining.
Yeah, of course.
Yeah, I had fun listening.
Yeah.
I'm glad you
I,
did.
all right. Peace.
Bye.
Peace.
Bye.
Star Wars and so entertaining. Bye, Rach. Jane. It's past my bedtime too.
Yeah. Yeah, we'll talk again soon. See you on tomorrow's stream. The Craig and Toon.
I thought it was supposed to be today, but all right.
Wait, what? What's today?
Today's Wednesday. They normally do it on
Monday.
Wednesdays.
Yeah. Sorry, what's today? I'm so confused about what day it is.
Yes. Welcome to my
So then
life.
tomorrow for Toon's Thursday stream.
Or whenever. Or in the cat over in the tune right now if you want to go over there.
Yeah, I'll probably jump in for a few minutes, but I'm definitely gonna have to get to bed.
See ya.
Bye. Okay, yeah, that's fine. Okay. So, I had shared some um stuff. Since you're driving, you can't do like the simulations or any of that stuff on while you're driving. I don't even think one of them works on the phone, but there was one. If you get a chance, the middle one is about like the actual physics behind the previous thing that I shared. When you get a chance to just look at that, it's pretty cool. But yeah, so I just kind of went over the basics of the types of black holes, so stellar mass and supermassive mostly. And I didn't really do much on intermediate. So I've heard of it, but I haven't actually run it yet. Most of my simulations I just do through UNL. But I've been finding other ones. The thing that I shared, I can't like, I don't know if that's like the name of it or something, but, I mean, it was pretty cool, but that's like the only one that I've done outside of UNL so far. I've been trying to find other ones. Let's see. Yeah. I've always loved. I did so much research on black holes like years ago, and then I just kind of stopped, and I was like, I should probably find all of these things that I used to have. And I actually had this one simulation that was really cool. It was an HR diagram, but you could um, put the star that you wanted to see through its cycle. And the one that I was playing with that is actually on the screen right now, this one's not the same. This one just kind of, it doesn't show you the trail, and then it just kind of, if it's a black hole or even a neutron star, it just kind of disappears. But the one that I did have was like it would trail along with it, and then it would tell you what it was in the end. So like what type of supernova it was, and then if it became a neutron or a black hole. Let me see.